Hello everyone. I'm Sanjana. Me, along with my friends Maanusri and Akhil, are implementing the EleNa elevation based navigation, which is a web application that finds an optimal route between 2 points by taking not only distance but also elevation gain into consideration. EleNa would be used by runners, bikers, and hikers alike in order to find routes that range from as an easy stroll to an intense workout. In our implementation, we focused on developing a complete system, including a user friendly UI and an effective algorithm. Next, my friend Akil is going to explain the design implementation.
Coming to the design architecture of our project, we have our project in two parts, the front end and the back end. We have built our user interface, the front end part, using HTML and JavaScript. Through this interface, we get inputs from the users like the source, destination, the expected elevation gain type. The user can select the max elevation or minimum elevation gain, and also the user can select the total limiting distance between 2 points, which is expressed as x percentage of the shortest path. So once the user submits these details on the UI and then clicks on submit, a request is made to the backend. The app server, which uses the Python and Flask, receives this request. Then it will invoke the map controller, which will get the latitude and longitude information, the map data, the elevation data, and all other details from the map database. This will be used by the actual routing algorithm for the required optimization. Uh, after calculating the shortest path using the given configuration, the route controller is then invoked with this information. So based on the user's choice, if the require the max elevation or the min elevation, this will choose a suitable optimization algorithm to return the best possible route. Now, then the checkpoints are also passed along with the best route further. Now, this best route metadata is then passed on to the front end, which will render the route or the path on the map. This highlighted path can be used by the user for their needs. So, in our application, we are actually rendering the two paths on the UI to do a comparison. The further details about the implementation and the demo will be continued by Manushri.
Now coming to the demo of our application, we have designed our UI in such a way that it is intuitive and user friendly. So here, first I'll walk you through all the buttons and options which are available for the user when he hits our UI. So here you can see the user is first given two options to either enter the location of the source and the destination manually or select on the map. So first when he clicks on the enter location button, two input fields appear where he can enter the source and the destination addresses manually. And when he does this, he'll not be given the option to click on the map. But here when he selects this select on map option, he'll be able to click on any location on the map, and the latitude and longitude information of these locations are displayed clearly over here. So he'll be able to select both a source and the destination and not click on any more locations. So these information is stored over here. Then he's given a field where he can enter the limiting distance percentage of the shortest path. So that can be entered here. And he's given a toggle button to choose if he wants the path to have a if he wants to minimize or maximize the elevation gain of the path. So there's a toggle button for it, and also he's given an option to select the algorithm which is going to uh, generate this path, that is either A star or Dijkstra. And there are two clear fields where once the computation is done, both the distance and the elevation gain in this path will be clearly displayed in these UI elements. He's also given an option to reset all his selections. So say he's clicked on all these markers and all these toggle buttons, and when he clicks on reset, the UI goes to its original state so he can do more computations on this page. So I'll walk you through one of the flow. So say I'm entering my location manually. So say I'm going from Amherst College to Winchester Commons, and I give my X percentage to be 50%. I want to maximize my path using A star algorithm, and I submit it. So now if you see, you'll see a clearly two paths visible here. One is the shortest path between the source and the destination, and the other would be the path with the maximum elevation. Now say I'll walk you through the other flow. So say he wants to select it on the map. I first click it on reset and everything goes back to the initial state. Now I select on the map any 2 points, and you can see the values are populated as always, and I give a value and I select Digistro algorithm and I submit. Again I get clearly two paths. Here both the paths are the same, both the shortest and the EleNa based path are the same. So you can see that the paths are overlapping here. So why I would say our application stands out for this EleNa based path generation is that the user can clearly see both the routes and he can decide for himself which would be the best path. Like he'll be able to visualize both these routes on the map real time. And okay, so now I'll cover some of the UI tests which we have placed, which are in place in the application. So for example, the user will not be able to enter any negative values for x. Like say he gives an invalid value for x, our system will not accept it. So it'll give an error pop-up saying him that he'll have to enter a valid x value for computing the path. So he changes it to say some value and he wants to enter a location, but he just specifies the start location but never specifies the destination. Then that's also going to be a problem and our application will detect that. He'll again get a pop-up saying that you need to enter valid source and destination. So like this we have kept a number of checks in place both in the UI and in the backend for our application to run smoothly. Thank you.